Welcome to our today's lesson. We are looking at mechanical engineering science and our topic motion. Actually, this is the fourth lesson on this particular topic. Let me take you back to our last week's lesson when we looked at the relationship between a linear motion and angular motion, and we were able to establish the relationship as linear velocity v being equal to angular velocity omega multiplied by the radius of the circle r. Also, we established that linear acceleration a is given by angular acceleration alpha multiplied by the radius. So these two equations gives us the summary of the relationship between linear velocity and angular velocity. In this particular topic, you will also very importantly remember the three equations of motion, both the linear motion and the three equations of angular motion. Today we want us to look at an example of a problem that will help us to cement and actually link the relationship between linear motion and angular motion by looking at an example. So for example, if you are given that the road wheels of a motor vehicle increase the speed uniformly from 50 revolutions per minute to 1,100 revolutions per minute in 40 seconds, calculate the angular acceleration of the wheels in radians per second squared if the diameter of the wheels is 0.7 meters. What is the linear acceleration of a point on the tire tread? So basically, if you are given such a problem, as usual, you will start by doing analysis, and in the analysis, you'll be able to break down and see what are parameters that you are given so that you can use them to find out what you are not given. Like for example, in this particular problem, we are given that the initial speed n is 50 revolutions per minute, and the final speed n is 1,100 revolutions per minute, and the time in the change of the speed is 40 seconds. The question is, calculate the angular acceleration alpha if also you are given that the diameter of the circle is 0.7 meters. Establish the linear acceleration a. So now from this, we can be able to use the information, the linear speed, to calculate angular or initial angular acceleration omega 1, and we can also get from final speed the final angular acceleration omega 2, and that we can get from this relationship that from angular acceleration is equal to 2 pi n over 60. We can use that relationship with the n that we are given, so that now initial angular acceleration will be equal to 2 pi multiplied by n, which is in this particular case is 50 revolutions per minute, divided by 60. So that now when you work out correctly by multiplying, then you will find that initial angular velocity will be given by 5.24 radians per second. Remember, the units for angular velocity is given by radians per second. So that is the initial angular velocity. Then final angular velocity omega 2 will be given by 2 pi multiplied by the final speed, which is 1,100 revolutions per minute divided by 60, and when you multiply and divide, you will get 115.2 radians per second. So you can go ahead then and confirm by multiplication to be able to get that. So that now, once you have established the initial angular velocity and final angular velocity, you will go and use the relationship from the first angular equation of motion, such that from final angular velocity omega 2 is always given by initial angular velocity omega 1 plus acceleration, which is angular acceleration multiplied by time t. So now the question is to calculate the angular acceleration alpha. So if we can make alpha the subject of the formula, then we will get a final angular velocity omega 2 minus initial angular velocity omega 1 divided by time t. Now you can simplify by simply replacing in the values. 115.2 for final minus 5.24 for initial, and then divided by the time, which we are given as 40 seconds. And when you multiply and divide, you will get that the angular acceleration alpha is given by 2.75 radians per second squared. 2.75 radians per second squared. So we will have established the value of alpha. Now, part 2 of the question: are you able to calculate the linear acceleration A, given that the diameter is 0.7 in that particular case? Already, we have established angular acceleration alpha as being given by 2.75. So we use the relationship between linear velocity and angular velocity from A equals to alpha r. Then you'll find that from this diameter equals to 0.7, we can get r equals to a half diameter, or diameter over 2, which is 0.7 over 2, and this will give us 0.35 meters. And now you can go back and get acceleration A being given by the alpha 2.75 multiplied by 0.3, and when you multiply, or 35, when you multiply, you'll be able to get linear acceleration as 0.9625, and this is meters per second squared. That will be our answer when we calculate. So therefore, we will be able to get quite a number of problems. You'll be able to use them effectively. I said that ensure that you understand the equations of motion, both linear motion and angular motion, and also establish the relationship plus other equations like the relationship between speed in revolutions per minute and omega, and it will be very useful. Otherwise, thank you so much for tuning in. Kindly subscribe to this channel so that you can be able to get all lessons that will be coming up after that. Thank you.